Alright. So a geometric sequence is where you keep multiplying the same value over and over. Page 536. So number one, can you tell what they're doing?
Dividing by 2.
They're dividing by 2, not quite, close.
Number by 4.
Oh,
No.
well, okay. The first one is dividing by -2, right?
Mm-hmm.
But what's negative 16 divided by negative 2?
4.
No, positive 8.
Oh.
Okay, so in other words, it's not the same number over and over, so number one is not a sequence. So we're just going to put number one. No. No.
I have numbers
Number 3. What number would they be multiplying by over and over on number 3?
1.
0.
1.
No, yeah, do
Multiply by 0 turns into 0, right? Multiplying by 1 keeps it the same. So you put yes. Now, yesterday we called the number they added the difference. Today we're calling the number they're multiplying the ratio. So the ratio is 1. The common ratio. Okay, actually we should probably do number 2 for practice also.
I'm going to do 4.
Multiply by 0.25.
By
No.
1/2.
Okay, so, no,
What's 1/2 of 3?
it's 3 times what equals 1? You guys see how I did that? It's 3 times what equals 1? How do I solve for
1/3.
divide by 3? It's 1/3. So on, yeah, that's for number 2. On number 4, do you guys remember what the common log of 10 is? It means 10 to the what, you can plug it in the calculator, but it's 10 to the what equals 10.
The 1.
1. The second one,
This
Well,
one.
or
just
just log
plug in
10.
log of 10. The second one is 10 to the what equals 100. 2. The third one is 10 to the what equals 1,000. 3. So basically it's just 1, 2, 3. That's a geometric sequence, or it's an arithmetic sequence because it's adding 1, but it's not a geometric sequence. So you just put no for that. Number 5. The reason they put that on there is because the chapter before this is a trig chapter. But why don't you guys go ahead and plug in, somebody plug in cosine of pi, let's see what we get.
Oh.
Wait.
Cosine of pi.
5.
Should be a negative in front. Do you see a negative?
I don't see a pi.
Cosine.
I got 0.9.
I got
Oh, no, no.
0.9984.
Okay, never mind, it's positive 1. Okay, positive 1, it's inexact, but it's supposed to be a 1. And what's cosine of 2 pi?
Wait, how do I plug this into my calculator? Because the only cosine thing
It's the same.
I have is like cosine to the -1. I got 0.9939.
Oh, well, okay. Yeah. So, I don't want to explain all this. It should have gone -1 to 1 to -1 to 1. Okay? The calculators probably aren't set right. It's got to be in radians. We didn't learn about that junk. But anyways,
Oh wait.
what is the...
I got it.
If your calculator is in radians, it would get this. Okay, anyways, what is the pattern here?
Oh.
Minus 2
Negative
plus
one,
2
negative
minus
one.
2.
Times -1. Times -1.
Oh yeah. 2?
Add 2, subtract 2, but that's not a pattern. So, times -1. So we're going to put yes, r equals -1. 7, state the next three terms of the geometric sequence. What are they multiplying on 7 to get from 9 to 6? Okay, 9 times what equals 6?
Divide by 9 is 6, right?
Oh, 1/3.
Close.
Which is 2/3.
2/3. They're multiplying by 2/3. Ooh, yuck. So, you do 6. I'm looking at number 7. You do 6 times 2/3. That's the first. Well, it's the third term. And then you do whatever that is times 2/3. Whatever that is times 2/3. What is 6 times 2/3?
4.
4. What is 4 times 2/3? 8/3. What is 8/3 times 2/3? Times 2 is 16, times 3 is 9.
16.
Oops. So that's the next three terms in the sequence. Number 9, what do you multiply to go from 14 to 10? So it's 14 times what equals 10?
10 over 14, which is 5.
Right, 5 sevenths. So what is 10 times 5 sevenths?
57, or 50 over 7.
50 sevenths. What is 50 sevenths times 5 sevenths? 50 times 5, 7 times 7. What is 250 times 5 sevenths?
Well, then you do,
250 times 5 is 1250. 49 times 5, 243.
Wait. I got 49 times 5 is 245.
49 times 7. Did I say 5?
But yeah.
We're multiplying by 5 sevenths, so top times 5, bottom times 7. Alright. You can just do fraction times a fraction. There's no fraction. Alright, number 11. Recursive formulas. So what's the pattern on 11? What are they multiplying by on 11?
1/3. No, negative 1/3.
Right. 9 times 1/3 is 3, but you need the negative to make it negative. So they're multiplying by negative 1/3. So we did this yesterday, so you probably will kind of remember this. Recursive formulas look like this. You guys remember that? Then yesterday we put like plus 3 or whatever it was. But today it's multiply. So on this one it's multiplying by negative 1/3. So you just put that right there. It means each term is equal to negative 1/3 times the last term. Each term is equal to negative 1/3 times the previous term. That's what it means. And remember also we said what the first term was, which on this one is 9. Recursive was like the easier form.
Wait, so you just write the.
I know we got confused by what the little n and the little n minus 1 meant, but it just keeps track of which term you're talking about.
Is that a comma or a 1 in there?
This is a comma. This is the formula. This just tells you what the first term is.
I'm ready. What? Christmas.
For what?
Christmas.
Christmas.
I don't Christmas.
You got about 9 months? No,
I'm
8
ready
months
for 4th
left.
of July.
Shut up. Why? It's not.
Okay. 13. Let's see. So, what are we multiplying by in 13? How do you get from 16 to 12?
3/4.
Right. 12 over 16 reduced to 3/4. So the formula is going to be 3/4, comma, that one is too big. I don't know why I did that. what on number 13?
60.
Because you need to know where you're starting from. You keep multiplying by 3/4, but you need to know that you start at 60.
How come we write the A bigger than the N?
Because that little n is not actually a number. It's just to keep track. It stands for, like, when I say a sub 1, that doesn't mean I'm multiplying by 1 or anything. It just means the first a and the second a. So it's not like a normal real number. It's just a number that keeps track
So
of it.
it just represents like.
It just keeps track of which term you're talking about. So if this was like a 2, this would be like a 1.
Oh, so if you're finding like the 20th, like thing,
Term.
just plug that into N.
Right.
Oh,
Yeah, it does, yeah, and you're not actually multiplying by 20 or anything, you're just saying the 20th term equals 3/4 times the 19th term. This is what it's saying. It's basically saying each term is equal to 3/4 times the previous term. That's what the n and n minus 1 mean. Whatever n is, this is gonna come right before it, n minus 1 is right before that. Later on, actually the next few problems, we are going to write n like a normal n because we're actually going to multiply by it. So this is called recursive, and n doesn't actually do anything, it just tells you which term you're talking about. But on these next problems, it's called explicit. It's a little bit different. So on 15, it says write the explicit formula. This was kind of the hard version on yesterday. It's not that hard on today, so it's not bad. So what you do is, it starts off the same, a sub n equals. For the geometric sequences, you start with the initial term, which is 2 on number 15. And then what value are we multiplying by over and over? 5. You put the times 5 next to the 2. But here's the problem. How do we multiply by 5 over and over and over again? How do I show that? Exponents do that. So guess what I'm going to put in the exponent up here?
X.
No?
N plus.
N?
Plus
Okay. Almost.
And minus
You're really close. Okay. What would happen is if I wanted the first term, I would put a 1, if I turn into 1, I would put a 1 up here, and I'd get 2 times 5, which is 10. But the first term is supposed to be what? 2. So how do I not, 10 would actually be the second term. So how do I fix this?
You put 2 there.
If I put a minus 1 right here, it turns my 1 into a 0. What's 5 to the 0 is 1, just goes away basically. And now my first term is 2. My next term, when I plug a 2 in right there, it's going to actually multiply by a 5. The next term, if I plug a 3 in there, it's going to multiply by 5 twice. And so on. So that's basically it. So I put the first term, the multiplier, which is the common ratio, let's call it the ratio, and then n minus 1. That's how it works, basically.
Is that it?
Yep, that's it. Alright, 17. So what would 17 be then? A sub n equals, okay, you do the initial term
24.
times, what's the multiplier? Oh, we gotta figure that out. How do you get from 24 to negative 18? 24 times what equals negative 18? 24, negative 18 over 24, with the
Negative.
negative 3/4. So our multiplier is invisible on this one, but it was negative 3/4. And guess what else I'm gonna put? N minus 1. ConocoPhillips. Did everybody get an interview?
I have one
It's like 7
Got one.
7 people got one.
Landon, Kinsey.
Yeah, 7 people.
Has Charlie done hers yet? I don't know.
I think Charlie did hers on Tuesday.
Josh and I are the only ones with interviews today. Who's that for? Was it like weird?
It's just like, they basically just like look at stuff you put on your resume and then they ask you questions based on, it's not like hard questions, it's like stupid questions they ask you to see how you respond to it.
Like what? Like.
Like, I put that I've been to a bunch of different states, so you have to know my favorite state.
Sing it.
Randy, you're not even noticing. No, he's just ignoring
He
me.
did, but
He won the
Did you notice?
Actually,
I was gonna say.
they were doing it for like 2 minutes. I
I
thought when Caleb started, he would notice.
I'm just sad that I'm gonna miss fried rice. Mr. Steele's
let's
gonna
go.
buy like the whole hour plus fried rice, and it's the one day that I'm gonna be gone.
noodles and fried rice for everybody.
Bummer.
But I'm gonna come back. Like I'm gonna be.
Did you-
It's gonna be like
did you
3 o'clock. and
Tell them to
I'm
put
gonna-
some in the fridge.
Yeah.
Alright, let's finish this up. Ninth, yeah,
Oh,
19. Okay, so on 19 it says identify each sequence as arithmetic and state the difference. That's like yesterday's. Geometric, state the R, the ratio, or neither. So we're combining yesterday's and today's. So what is the pattern on number 19? Plus 2. So we're going to put arithmetic, comma, arithmetic had a difference, so we put D equals 2. That's what you keep adding by. Today's geometric had a ratio. Okay. 21, what's the pattern? This one took the other class a while to figure it out.
You just multiply by 2.
No, plus 2, plus 4, plus 6.
It looks like times 2 to start with,
Oh yeah.
but 8 times 2 is not 14.
Plus 2, plus 4, plus 6.
It's plus 2, plus 4, plus 6. So what would that be?
Geometric.
That's neither.
Neither. Because for arithmetic, you have to add the same thing over and over.
Yeah.
So it's neither.
My Kobe, not Kobe, so warm and
Just go switch it up.
Oh, actually?
Did you open it
No.
yet?
Just open up. I don't know.
Oh, what are you doing? Did you see that Mr. Smith kept
Nothing.
the English class?
Really?
No, you're sorry. Probably not you.
You kept the chairs.
Yeah.
I wasn't
Alright.
there.
And he tried to act like it was normal.
What
He
did
acted
it
like
say?
nothing happened.
Yeah, he said that he had seniors do that.
So did you guys just sit backwards?
Yep.
Yeah.
Well, no, we just sat facing the other wall. Whoa, backwards. Yeah. Oh yeah.
No, we actually.
I'm not like it.
Alright, number 23.
I was on the same side, but.
How we choose.
Wait, we're going to 24?
23. What is the pattern?
Plus 1.
Plus y, yeah. 2y plus y is 3y, right? So it's a what?
Arithmetic.
Arithmetic. And the difference is
What?
Plus 5.
Yeah.
Very close to like 4.
you're more Josiah than Josiah.
We're trying to say yes.
Wait, so if you multiply